yes, let's talk a little bit about how would we configure all of these things. Like you have downloaded the repository, compiled the firmware, walked through, like went through all of the tutorials. Let's see how to configure all of this stuff. So I'm going to intentionally do a compilation of the firmware only, because that will tell us, I mean, that's everything that we need. I'm not going to have a control system compiled. So basically I'm going to compile everything, well, I guess everything in this block, except for the Simulink deployed part, because all of the communication related stuff and everything related to that is actually part of the firmware. So you would only need to install this PX4 PX4 Simulink input output framework GitHub repository. This is purely a firmware upgrade. All of the configuration and parameters are all part of that. This is merely an example. Again, this RTV that I was walking through, the tilt wing, it was just merely an example. It does contain these interpretation blocks, but they don't, as I mentioned previously, they don't have any logic in the Simulink, because that's all part of the firmware. Alright, so let's do that. So we can compile it in different ways. Again, if you watch those tutorials, we can compile it through the MATLAB Simulink, like UV Toolbox setup, or we can just directly go through the developer setup that PX4 provides and do that. It really makes absolutely no difference. So the first thing we need to do is, obviously we can connect our physical PXOC cube. That's what I'm going to do. I started cube ground control. And you probably are going to be better off removing the SD card altogether, especially if you use that. And then resetting everything to the defaults. Just start over, make sure that no other configuration that you used in the past will conflict with anything you're doing. To do that, again, as a quick reminder, you would just go to parameters, once you've connected to your board, of course, tools, and then reset to firmware. Not vehicle, but firmware default. Why firmware? Because this is the most, this is basically factory default, everything is erased. We're not going to do anything except for now we want to also erase the firmware. The best way to do it is to just go through the standard firmware upload process, and note I just keep it on the default, whatever it is. It's a totally different version from the firmware that I'm going to be using. So this is just to make sure that there is no parameter or anything being recycled. We're just going to do this a couple of times. Like once we upload the firmware, the stock one, we can do this factory reset once again, just to confirm that everything has been definitely erased. You don't probably need to do this step. It's optional, but I just found that this actually fixes some of the problems when you run into things that you just can't really explain why your board behaves the way it behaves and not the way you expect it, especially when you haven't done anything with it yet. But while that's happening, I'm just going to go to the part where I have compiled my firmware, and that's the same one that I'm providing in the repository. You can have, once you go to your PXOC Autopilot build directory, or I guess firmware directory that will be built, and then you compiled your Cube Orange firmware, and then there will be this Autopilot Cube Orange default. I mean, the same name that your configuration file, the CMake file, the PX4 firmware .px4 file. That's the one you need to upload. It's the same file, it's the same process whether you're doing just with how I did it with terminal built using just stock PX4, modified PX4, or PX4 compiled through Simulink. So this uploading process is the same. But you do need to use if you modify something in Simulink and you want to use that, you need to go through MATLAB and the tutorials that I provide. Alright, so let's just reset this once again, just in case. It's all good. Alright. So we have reset it multiple times. You see it's a brand new board. What we are going to do now, we're going to go again to firmware tab. I'm not going to upload one like the new firmware once again. There is no reason for that. We've done 2 factory resets. Should be more than plenty. We're going to upload this upgraded PX4 firmware, but it doesn't have the controls or Simulink deployed code on it. Just so we go over these settings and configuration stuff incrementally. Alright, so what we need to do is, because this is a custom firmware now, we need to go to custom firmware file, click OK. We then browse to whatever is the location of our firmware. Then for me, that's just on a separate virtual drive. PX4 Autopilot 1 is the same file I just showed you. You're just not going to see everything else here because it looks specifically. Don't use the binary like this .bin file. Use this. This is the one prepared for the upload. Default.px4. Right. Same steps, same everything. Once this is uploaded, we're not going to go through like the standard configuration. For example, like I don't want to do right now calibration of any sensors or anything like that. You know how to do that. Or if you don't, you can watch the tutorials online, how to do it with the stock firmware. It's the exact same. There's no difference there. But we're just going to cover the changes that I've made. And once this uploads, alright, so this firmware uploaded. Yeah, obviously it will notify you once it has reconnected that there are some problems. Again, we're only going to configure the things that we need. So the very first thing you should do is go to airframes. And, oh, by the way, before we even do that, just to confirm that the firmware, it's the correct firmware, you can go to Mavlink console over here. Click on this button, Analyze Tools, Mavlink console. You can use a top command, for example. This is just going to bring in an interactive shell. You can see all of the, or some of the module, if not all of them, that are running. You can actually see Mavlink Wi-Fi, like UV can driver that is running, all of the modules that are basically running and execute rate control. Not sure what that is running, but I think it shouldn't really conflict with anything. So what we want to do is, yeah, let's hit on enter to kill that. That's how you do that. SM control. Oh. Sim control mod. Status not running. Okay, so this is where it's important. We have compiled the firmware. We just uploaded it. And remember how I mentioned that there is this sim control mod or Simulink basically control mod module. We need that for everything to function correctly. Right now it's not running. The main reason, because this is the factory default setting. This is all good. You don't need to do anything on the SD card. Oh, clear doesn't. Never mind. All right, so this is just, again, we know it's there, it's compiled, it exists, it understands that command. But unfortunately, it's not running. And the reason for that is because all of the custom sort of startup stuff and disabling of some of the custom logic, I moved it to a separate airframe configuration, so we can still use this firmware with some of the stock features. But basically, once you go to this airframe configuration screen, you're going to look for, yes, so this icon over here, click on the drop down, you're going to see a tilt wing tricopter airframe. This is what we need. apply, and restart. Yeah, so once the board has rebooted and reconnected. Yeah, so we are connected. Airframe is selected. You see this is no longer red, tilt wing tricopter. We go to Analyze Tools. Again, the same screen. Oops, no, Mavlink console. We can do top. I mean, just again, confirm what's running. You can immediately notice there are actually, well, I guess 2 modules. You don't need this, but there is this Simulink control mod. It's running, it's alive, it's all good. That's what we're supposed to see. You can also obviously check by running a sim control mod status. And it will basically tell you, yes, this thing is running, this is executing, it's all good. No problem there. I mean, this is just one way to confirm, okay, yes, my internal thing is running. In case you ever like make changes to it, nothing has crashed. Because if it did, obviously it wouldn't be running. We can stop and restart it from the command line as well, but that's usually not useful when you're flying. You want this to be automatic, right? All right, so you go through all of these setups, like the sensors, radios, all of that stuff, the flight modes, power, that doesn't matter. We go to power. We need to go to this UV CAN bus configuration. Apart from everything else is standard. The new thing that we need to do, because we are going to be using UV CAN modules, we need to go over here. You may have this disabled for whatever reason. Just go to UV CAN bus configuration. Again, this is factory default, which is just sensors automatic configuration. We want sensors and actuators automatic configuration. So the third option has to be enabled, which is sensors and actuators automatic configuration. I don't know why it doesn't show the full prompt. Don't do anything else. You don't need that. It prompted you to restart the PX4. Yes, let's do that. Because this is CAN related stuff. If something doesn't work relative to the CAN, again, just watch this video again. Make sure that you follow all the steps. Start over from the scratch. We have also, I'm going to provide some of the settings file that you can use. That should be as simple as just uploading those without any additional work required. But just so you're aware of what's going on the firmware side, let's talk about parameters. So this tab on the bottom, parameters tab, is where we configure all of the modules. And you can see that there is UV CAN module. There is UV CAN outputs. Technically, these are not really modules. These are like groups, parameter groups. They can be related to one module or even multiple modules. But let's start with Simulink control, sim control mod. So these are all of the parameters related to the Simulink control module. This is not all of them, only the ones that are being used. And that's very important. When you compile your own app, depending on how you define those parameters, they can show up in this group or any other group that you defined. That's again separate. But these are essential for correct functioning of this framework. It's nothing to do with parameters that you use in Simulink. It's more of, hey, how do I make this all work the way I just explained? All right, so let's start from the very beginning. We have all of these source selector or SRC parameters. The main logic there, you can click on that. It should have some description to it. But as I mentioned before in this presentation, somewhere over here, remember we are getting some of the topics. They're labeled here inside of the Simulink according to their messages, but those can come from different sources. And obviously the labels will not be updated automatically in the Simulink, so that's something you should be aware of. you have these sources, right? So this one specifically, it's called SM ACC or acceleration source. And we can select 2 different topics that provide acceleration information that is supported. We can use vehicle local position, or we can use vehicle acceleration. If you know what you're doing, again, you can select either one of them. It doesn't matter for the framework. It will just function as is, but you should know what you're using. The parameter configuration file that I'll provide, it will use and will have all of these preset to the values that we're using for the testing. But it's the same thing like for the velocity source, all of these. There is this extra thing that I want to talk about is PX4 ARM source. So this is one of the, I guess, quote-unquote control parameters, or related to like, or I guess this is more like a safety parameter. It's very important because, well, it has a whole bunch of options, just like if we were to go to command option or anywhere else. But let's talk about ARM source. So this is the source for the arming flag that is being sent into Simulink, but as well as used throughout the vehicle. So it's both. So I should also, again, explain it here. This is an override as well. So by default, it's set to PX4. So it's doing everything that the stock PX4 is doing. And this is the ARM flag that you will see as part of the inputs into the Simulink model using the input-output framework. We're going to use that. Normally that's what you're supposed to do, but then you can explicitly specify. For example, you want to use inbound control message, whatever flag is part of that input that we're sending to our vehicle, right? Remember how we talked about these 2 packets being the same? These are inputs to the Simulink model, but they're also they can be inputs to the PX4. So this is where you decide. If you are sending and assigning ARM flag directly, and you're sending this inbound control, you can grab its ARM flag and override everything internally related to arming from that flag, just as long as that's obviously reliable. I mean, it will be only as reliable as the value that you assign. That's one. Same thing, I mean, these 2 messages are pretty much the same inbound message and inbound control message. There is also this RCN input. This is another topic internal to the PX4. This is the stick or raw stick values from your RC. It's not actually what this stock PX4 is using. It interprets those further. But if you just want to assign your ARM logic directly to the stick bypassing a whole bunch of other things, essentially this is for avoiding all of these 3 topics, are to avoid and disable the built-in safety checks, because they will be directly just assigning an internal state of armed or disarmed for the entire vehicle based on values coming in through any of these messages, either through sticks or maybe these inbound messages through whatever has assigned them. But it will not do any checking on them. So again, it's up to whoever provides those to make sure that those are safe. In addition, there is a manual override to where we are setting internally and externally. It's just like the vehicle will be always either armed or always disarmed. Again, you probably shouldn't do anything with propellers attached or anything that can be dangerous with these flags. And normally I would assume you're flying with this PX4 flag over here, unless you're doing, again, some testing. So this is more of a need-based if you're doing some testing and you want to disable some of the functionality. There is also this SM, the very top option, SM command option. This is a general flag. It doesn't do anything on its own. This is just tells you that, hey, there's another flag, SM command option, that governs where this data is coming from. This is just in case you want, we'll explain that later, but basically let's keep it at PX4 for now. because we can just arm the vehicle even when it's in the current state as it is right now. Okay, armed. See, the vehicle is armed, although we have a whole bunch of errors and we were not supposed to even arm because we haven't done any calibration. But we can, again, override all of the safety using those flags. So you should not use those if you're trying to fly and actually do something in the field, because these can be quite dangerous. Alright, so let's do disarmed, just to disarm it and then switch it back to PX4. Alright, so we're not ready again for arming. That's what PX4 tells us. Alright, let's proceed, and I'll explain the other flag or the other option. We talked about arm. Again, attitude source. This is similar to how all of the states can be coming from multiple or like other messages. Maybe not default, maybe something else. You can decide on your own what you're going to use. There are also these auxiliary channels. If you look at the structure of all of the control inputs, you know that there is an armed field that we just talked about. There are these roll, pitch, yaw, throttle channels, and I kept the same naming convention that the PX4 and Q ground control is following. Then there are also auxiliary channels 1 through 6, so aux 1, 2, and so on. And I have added, so up to aux 6, all of this is the same for the stock firmware in terms of like they use the same naming convention, and I try to follow that logic as much as I can. I also added, just for future reference in case we need to expand this, extra control channels, extra 1 through 6. You don't need to use any of these actually. These are just an extra optional input arguments that you can assign from different places internally within the PX4. So if you look, for example, it's just what shows up first, but auxiliary channel 1 source shows up first. Let's talk about it. If you go to options, let's select just the longest one so we see everything. Alright, so we have this SM command option was selected as a default, just because, again, we're going to talk about this when we get to that parameter. But this is like the default option, the global parameter for all of these inputs. We have manual overrides. So we can set manually values, switch low, mid, or high. This refers to if you had a 3-way or 2-way toggle switch on your RC, you would have it either at always on at position 1 or high, or at -1 position all the way low. So if it's three position switch, you're gonna have some middle values which should probably be around 0. So this is a manual override if you just want to like manually set that value internally. Again, do not use advanced settings and try to manually entry something, because these are parameters. They don't actually this is not the actual value. No, you use these flags to tell the firmware what the value should be set to, but I'm not exposing that for safety reasons. All right, then there is this, that we can get our control commands related to aux1, auxiliary channel 1, from inbound message or inbound control message. And again, as long as all of those inbound control messages are sent such that this structure is respected, I mean, these should be the same everywhere. The first 18 elements should be matching this structure. Then you see that there is no problem with that. You can use either one and override it manually. There is also RC input. So this is, again, directly using the stick values that have not been checked by the PX4. Can be beneficial in some cases, can be detrimental in others. Just like with the ARM switch. manual control set point. This is actually the UARP topic that is used by default by the PX4 firmware, as far as I remember. We didn't really use that. We used, I think I was always set to this default. But this is okay. I mean, you can select this one as long as you have configured firmware properly, you didn't disable it. Because you can, for example, tell PX4 to generate this RC input from manual control set point, and that's where you're going to use RC input. But let's keep it again the same at the command option. Basically, we're not using any of these overrides. We're just telling, hey, this is decided by some other parameter, which is called the SAM command option for now. All right, and it's very similar pretty much for all of these sources. But let's talk about this command option, because this is an option for a lot of parameters. And the reason they refer to this one is just because there is some general behavior that you probably want to switch for all globally. Like, you don't want some special case for aux1 or aux2 coming from different sources. Maybe you do, but that's why this is exposed. But generally, probably just want all of them to come from your RC or from your I don't know, Simulink inbound message or something like that. So this is just a convenience. Yeah, by default, it is set to manual control set point because this is the default. Actually, what I've been using most of the time is RC. So the RC message generated from by the PX4. And then, for example, the typical setup was, okay, I'm going to grab this RC input message because it has all of the channels I need. Then I'm going to go to ARM switch. I'm not going to use SM command option, but I'm going to use PX4. And then I'm going to do, for example, my PXHawk. I need to do, like, I'm going to use, for example, joystick inputs or something like that. Or maybe I want to generate this RC input because it will not be generated by default in most cases. Yes, so you would, for example, on your here link, by default, it will be sending your commands from the RC, like the actual here link, as set point, I think, manual control set point or something like that. You can use that, no problem. It's just a lot of times it's convenient, and that's what's been more thoroughly tested, is using the classical RC message. When you have a regular RC radio, not here link, plugged in into the S bus, usually what happens is it publishes this RC, raw RC channel message. So this is what normally PX4 is using. If you need to switch it, for example, our here link, and you want to probably use that RC instead of manual control message, then you would need to do this on the here link, virtual RC by joystick. So because here link is just using joystick input, and it sends that over as manual control set point or something like that. You would need to go on the here link and do this virtual RC by joystick. You can probably do this on PX4, on PXHawk too, and check which one works better for you. I don't think there's going to be any huge difference. But again, the exact configuration, you can take a look at that in the repository. I'm going to upload the exact settings, but these are just the parameters that are important. But this is, again, part of the stock PX4. All right, so sim control mod. Let's go back here. So we set it to RC input because this is some of the default that I personally prefer. Then there are other parameters. Calibration, ignore this right now. You can enable or disable. This is a flag that will send a different mode. Yes, mode, that's what we call it. So mode, flight mode. which is again one of the inputs over here. Yes, mode index. Yeah, you see there's this mode. If you are using RTV settings and the control system, internally this mode is regenerated using just raw stick input. So we don't use calibration flag here, we use that in, just ignore this part, you probably don't need that. But you can use that. You'll see this behavior, like it will change the behavior of the mode that comes into the Simulink model. You just have to test if that's appropriate to you or not. And all of this, by the way, can be just read in the Simulink control module over here. If you go to your firmware modules after you have installed everything, you can browse the files. If you go to Simulink control mod, alright, if you scroll all the way down, or pretty much all the way down, almost till the end, you'll see this publish inbound sim data. This is publishing all of the data, as I mentioned, available for the Simulink to grab. And you see that's where we are retrieving all of the states and other things. But the thing that we talk about right now, which is probably the most involved part that you just need to be aware of, unless you're using, again, a pre-configured setting file that has all of this dialed in already, is control vector, which is, again, part of the debug array that we're sending. So if you go to where this control vector is generated, there's this function on the top, update control inputs, and you can trace that. So the first 16 entries, they're going to be assigned, but there will be multiple sources for that. So you can see how I'm assigning different sticks, roll, pitch, yaw. They're all going to go in the same order is what we talked about. So these values are the same. But as I mentioned, the source of where those values are actually coming from, they're governed based on different parameters that we just explained. And this is a little bit too involved to cover, but the basic logic there is that, for example, a mode switch. If you are in calibration, and if you're using raw stick mode value switch or whatever, it will be -1. And this is another parameter, because basically the intent here was to allow people with different, I guess, mentality in terms of how they want to get stick inputs into their Simulink mod. Do they want to see the raw sticks, or do they want to have some other values and use those? But there is also this parameter, SM command option. Nope, sorry. Yes, so there is mode type. So there's mode source, as we talked about. We can get it from any other place, and there are also overrides for that. We can manually set it to different switch position or stick position. That's just up to us, or we can use the global flag that defines its behavior. But what I was going to show is that this specifically for the mode switch, there is this mode type parameter, which by default, that's what I use for my research. I use enums, I use just integer values, and it means something for my Simulink model. Basically go from 0 to whatever mode that I define, and that's one option. You can keep that and just roll of that, and this is actually defined again in the firmware file. I'm sorry, in the Simulink control mod. If you go to update sticks function, there is current mode, and you see these are all different mode assignment options. That's how they are implemented. So if you're curious to learn about it, you can check out the code. There is this structure defined over here, where I'm saying, which tells us what is each mode in terms of numerical value. And this is what I meant is like your calibration means one mode, 1, 2, 3 is just consecutive numbers on top. Then I have some other mode that I'm using for my own purposes. Basically, if you like this convention, if you want to keep on using that, you can use generic mode values. If you just want to see raw stick values, meaning that if this mode switch was to be written from the stick, so it cycles from -1 to 1 going through 0, so it's a 3 modes switch, then you can use this raw stick value. And I'm gonna pause real quick because I have a train. Alright, so as I said, these mode and throttle switches have special options, like throttle can be mapped to be from 0 to 1 or from -1 to 1 based on your own liking. And these two parameters, SM mode type and SM throttle, again, they only affect data or how the PX4 data is being interpreted and sent to the Simulink mode. If you again go back to this diagram, the very important part is there is nothing in there to tell me, or I mean the SM control mode is what you are sending. If you generate these SM inbound or SM inbound control messages from GCS, you have to respect that format. Or if you change that, for example, you want the command to be from 0 to 1, you set the parameter, but then inside of your Simulink model that generates this on the GCS side, you still send the command from -1 to 1. Well, that will not work because, I mean, I don't know about this. I'm just assuming that the data that you generate externally to PX4 is correct, and I'm not doing anything to it. And again, you can check these things by going over the SM control mod over here, because it has all of these things. Like, for example, update sticks function does all of these logics. Like, if you say that we're using RC input, it does one thing, right? And there is a special case for throttle. There's a special case for mode. If we want to map it from 0 to 1 to -1 to 1, well, we do that, but that's controlled by this parameter. And we'll do that. But this is only when we're grabbing it from the RC. If we're using inbound, if the source was set as an inbound message for that particular stick, whatever it is, these throttle and mode, you see those are not special cases anymore. I'm just assuming that you did everything correctly already because, well, how else would I know? And that's basically the logic there. And you can also check, like, there's this indexing part. And yeah, I mean, the same thing everywhere here. There's also this indexing. Note that I'm grabbing the value of the stick, checking its index, and placing it under the correct index. So what that means is I have also parameters, as I noticed, like this structure of the inputs, as well as the structure of the outputs. It's technically not fixed, although it's very... I would recommend against changing that at any point because I haven't tested a different input-output structure and when you change that. But basically, if you go to and look at the other parameters, you have this SM input map first. So this is the first input value, the control value. What is that? Well, that's raw. That's by default. But technically, you can assign anything. So it will get interpreted as pitch, yaw, or whatever. But then it can get very confusing because you have to synchronize everything. Your Simulink model and all of it with this change. So I would recommend against changing this part at all. It was mostly for my own purposes and in case I need to read these parameters anywhere else. There is also this concept of governor stick, or whoever is the primary pilot or decider. If you have multiple inputs, like what I explained earlier with RC, for example, HereLink, and GCS, both trying to control the vehicle. That's obviously not going to work out of the box. You'd have to set up, so for example, what is controlled from the HereLink, what is controlled from GCS, right? So you see all of these channels. You have auxiliary. For example, you want to map, I don't know, wing angle control or something, and that needs to come explicitly through either inbound control or inbound message. One is generated by internally, the other one is coming from the Simulink. Totally fine, you just set those. Or you can use, again, this SM command option flag. And if you take a look at that, SM command option, it also governs options for this switching. You can either force it to be always, all of those that refer to this flag to be always on the RC, always on the inbound, always on the inbound control message, or you can do the switching, manual control set point, or, and that's not visible, all right, manual control set point or Simulink control. Or the other option is RC input or Simulink control. The other option is inbound message or Simulink control. This Simulink control, again, is this SM inbound control. I probably got it all confused a little bit, but that is being sent from a Simulink model running on the GCS side. Just again for your own convenience, it's already pre-configured, so you don't really need to change these things, and you just use the parameter file that I provided. This is more of, hey, what does this thing do? This is what it does. But this switch between where this mode is actually being grabbed, it can be controlled by manual control set point, RC manual control, by a toggle switch on your RC. So if we set that, I mean, we don't have to set it, but for example, we decided we're going to switch between two options. And by the way, I think it should be an option here as well. No, never mind. If we go to governor, yes. Right, see this SM governor flag? Well, that's who is deciding on where we're getting the data. So for example, wherever the auxiliary channel 6 is being written, if it's on or off, it's going to be either one or the other control input source, which is manual control in this case, set point, or Simulink control. Probably you're going to set it to something like RC input from the HereLink or Simulink control from the GCS. That's probably more like what you're going to do. And then your governor is going to be, for example, auxiliary 6 channel. You don't change that. You can do any of the parameters too. And then you go to your auxiliary 6 channel. Yes, auxiliary 6. Instead of this SM command option, because this is now confusing, you would want to set this to, manually set it to, okay, this is always controlled by whoever is writing this inbound control message. Or inbound message, which, again, this makes little sense. But inbound control, because this is the one that is being published and sent from the GCS. Or you want, for example, HereLink RC to be deciding who's in control. So use that. So now, the way it's configured, aux6 that we just modified, aux6 is our governor switch, right? It decides who is in control. And this governor switch, the source for that is coming from RC, whoever publishes RC message. Should be a little bit confusing, I know, but That's why you're better off using the pre-configured settings file, just to make sure that this is all correct. Also, there are these extra SM extra channels, right? They were not configured as part of the standard or stock PX4. I made these basically parameters. You can set the value whatever you want. They're not used by anything. Like, I don't use them for anything at all. The benefit for that is, of course, you can just have these sort of pseudo real-time parameters being generated on the GCS side that have nothing to do with the auxiliary channels or regular control inputs. Then you can use them. I mean, you would just have to set again where this SM extra is coming from. Actually, never mind. These are always coming from parameters. Unless you set, if you are using Simulink control. Yes, if you're using Simulink control, so you're grabbing the data from inbound message or inbound control message written by Simulink model. As you notice, this is getting everything from it, meaning that it doesn't check for it. So that's basically what it is. All right, anyway. We never ended up using them, so maybe something is not thoroughly tested on any of these channels. This was more of a future expansion / hopefully we'll never use that. What did I forget? Okay. Oh, yes, so all of the communication stuff. Yes, the topics to be relayed back to the ground. So you see there's this SM Mavlink stream parameter, or SM Mav stream. By default, all disabled. We're not sending anything back to the ground. If you go to Analyze Tools, you are going to see basically standard PX4 PX4 topic with no debugger or anything. So what you need to do is go to Nope. So if you use Mavlink, which you are, you need to do there is a standard PixHawk parameter. Yes, so for example, you have enabled communication on telemetry 1 port, right? Whatever you enabled Mavlink config. The mode by default is usually set to normal. Well, if you want some of these things to show up, go to minimal Simulink. Switch Simulink on. So this will be normal plus some extra packages. Well, you don't need that. Yes, so Simulink. Mavlink config 1. Yeah, and I would just do that for all of the... Unless you don't want to see Simulink related data. This is just a way to disable that. Mavlink 0 rate. I don't think any of this. This is again custom to whatever you're trying to do. And then in the SM parameters, our Simulink module, as I mentioned, we have this Mavlink data stream. It's a double flag, sort of. You're just saying what you want to see, send or receive. For example, you only want to get the states that are coming out of the Simulink model. You don't care about what's going in. So you would select outbound only or inbound only accordingly. Let's do both. Alright, so the important part is none of that will be active until we reboot. Well, actually before we reboot. There are also the streaming rate parameters, you see. SM Mav out hertz, Mav in, so this is inbound and outbound. A little bit confusing, but let's say we do, I don't know, 30 or whatever you decide. I mean, these are parameters that are only active when you send something or I guess publish the data, because if you're not publishing, or if you don't have, like what we have right now, we don't have the control system also being compiled as part of the project, just to remove extra parameters that we don't need to see right now. Because don't forget, if you have some parameters defined in the firmware but they're not being used anywhere, they're not going to show up on the on the Q-ground control side. Alright, so we enabled, we restarted. Let's go back to Analyze Tools, and you see debug floater rate is available, and you can see this is an inbound message with array 200, array ID 200. I know we have enabled outbound relay as well, but this is only a single message. Normally this would flip-flop between inbound and outbound, and these would keep changing. But as I mentioned, there's nothing on the other side. I mean, there's no control model deployed, so there's nothing to publish the new outbound data, so it's not being sent. Like, there's no message to be sent, which is perfectly fine. I mean, it would be blank anyway because the data is not available. But this is how you see everything in the Q-ground control. As you can notice, it's streaming exactly at 30 Hertz as we have specified. That's probably it. Oh no, UEV CAN stuff. Yes, let's talk about this. So Simulink control mod. I think we are good. I mean, there is also ground contact flag. We can override that, or we can set it to other sources, or you may just ignore this altogether. I think the most recent project that I'm on for the tilt wing, we just ignore that altogether. There is like an override flag. I don't think you'll need that ever. But if you use some low bandwidth radios, but you just absolutely need to see Simulink data, you can disable everything else, so you will not see any telemetry, and it will only send these Simulink packets. Probably not ideal, since you want to have standard tools like your ground control also functioning correctly, so you wouldn't use that. But that's about it. Let's go to UAV CAN. Alright. It's smaller. Not too bad. Pretty much all of these are default, except for, remember how we went into power settings and configured automatic config? You can do it through here. That's about it. It's just a flag that we need for everything to work correctly. The rest is, the only important part is the safety. So the way UAV CAN works, there is a safety flag similar to ARM and disarm flag that is being sent over the entire CAN network. Oh, excuse me. And by default, it doesn't let any of the PWM expansion boards or actuators to do anything. They're just disarmed. Same way as with the vehicle. So I just added this override to where if you are actually flying, obviously you don't want that. Or if you are doing some testing with the board, you need to remove this safety switch. I mean, and basically arm the system. This is something that PX4 doesn't use, and it was not supported, and we use, I believe, AP per riff enables PWM CAN expansion board. So this is something in native to Autopilot. PX4 didn't have a support for it, so nothing would work properly. You just set this to safety off. It sends an Autopilot flag that we don't care about. Everything works as it's supposed to work. Okay. Alright, so this is just configuring the UAV CAN module. There was nothing extra here. I don't think I changed anything at any point. You can keep it all as a default. You can go to UAV CAN outputs. This is where configuration actually continues. Oh, interesting. I believe because I kept the SD card, the UV can settings for these were kept. No, never mind. It's just by default. That's what it says too. Never mind. I think I had a wrong default. Yeah, I didn't change anything yet. All right. So UV can outputs. It's a lot of parameters that are pretty much the same. Just for every channel out of 16 has its own separate parameter. That's really what it is. All right. So first of all, ignore the circuit breaker. I don't think it actually does anything, but just in case. If you ever do this from scratch, you may want to check this. No safety checks. I think it's not used. What you need to do is, by default, all of these disarm values are set to -1. It's not actually being. It's not -1 inside. It's going to write the default disarm, which is. Probably nothing. I need to check on that. Let's go and check that because that's important. So all of the UV can related stuff is inside of the drivers folder. They go to UV can. What I have modified is in here. Servos. Let's go to servos because this is not going to have anything. All right, so this is the part that updates all of the actuator outputs. We get all of our minimum maximums, right? All of the parameters. That's where we are reading this. Now circuit breaker is being used. Never mind. That's why we see it. Safety checks. Here we go. Yeah, you probably don't want to disable that. But you can. It's not super necessary. It just depends again. If you're using the settings file, which with what has been tested, again, I would recommend you just to stick to those things that have been tested. And confirm to work correctly. Yeah, it will use the internal default. Yeah, so, okay, so the max and min, the global one, is not set. We'll just use the internal one. That's good. All right. Anyway, so I mean, you can read through this more thoroughly, but the logic there is you would probably want to first go and look at these enable flags, right? You have UV can servo, and this is in the same order as everything else that we've talked about. So channel 1 over the UV can is 51, right? And this is your first output of the control output. The output vector of the Simulink. What you do is, well, you know what you're talking to, right? You said, for example, channel 1 is ESC. Set that to be ESC. Channel, for example, 2 is also ESC. Then you have, I don't know, channel 3 is a servo motor. You set this up. It changes some of the logic internally. Alright, so for example, well, I want my default actually to be 1000. Just in case. Alright, disarm. And then for servo number, for the servo motor that I've configured on channel 3, channel 3, I want that to be disarmed. When it's disarmed, it's going to be at 1500 PWM. That's basically as simple as that. Everything else, since it's not a valid point, it will use the default. regardless of if I think it's mostly for servo. For ESCs, when they're disarmed, they will ignore these values if it's set to ESC over here, and it will just go to, you know, idle, which is all the way down on the PWM range, 900 or something like that. It basically will go to very low PWM value. All right, so basically the logic is the following, right? Go to update outputs. We have, again, those two flags that we talked about. If it's in ESC, there is one kind of logic. If it is not in ESC, which is basically servo, right? We have a little bit different logic. So for a servo, if safety checks have not been enabled, we're going to run through all of these things, right? Which is basically if we're in the failed mode and the failed value is positive, we're going to use the failed parameter, like the value, the PWM value that was set for the failed location. If we are not armed, so we are disarmed, we are going to either use a positive value, or I mean basically if the disarm value was set, we're going to go there directly. If the disarmed value was not set, it's going to be -1, and basically we're going to enter this loop, which is basically, hey, we're just going to go to the 0. 0 in this case refers to the command in the range from -1 to 1, so this is middle point, exactly center point for your PWM range that you have selected and configured on the other side, and in the parameters here as well. All right, so if we are armed, so over here, we'll just obviously map the actual command and apply the polarity thing. Just flip it in case we need to, because there is an additional parameter. If you scroll over here, there's this servo reverse. You can reverse it, and that's polarity flag. And basically it flips the direction where the servo moves when it sees positive command. If we go to ESCs, it's even sort of simpler because, well, first of all, I don't want to disable safety. I realized that later because we want that to be always enabled for servos, for ESCs, I'm sorry. And if it's disarmed, we are going to set a specific command, just whatever is the lowest value we are allowed to send, which is -1, and it's interpreted hopefully to 900 on the other side. If it's something else, well, it may not work as intended. Just configure your ESC outputs again to 900 PWM on the other side. If it is armed, obviously we're not going to be here. We're just going to map our command and can proceed with that. And this is an important part to realize is, yeah, these are technically like PWM values over here just for convenience, but we're not actually talking PWM within PixHawk, right? As I noted on this diagram over here, we're just sending signals. Over CAN, there is actually no concept of PWM. You have a normalized signal mapped between -1 and 1. -1 is mapped to whatever is the lowest setting that you have configured on the PWM CAN board itself. Like you need to configure that value. And -1 will be mapped to that unless you have reversed it. If it was reversed, then -1 will be mapped to maximum. And as simple as that. But that is, again, it's separate configuration on the PWM CAN board, and you better match that. The main idea is that we have assumed that the lowest value for or pretty much for everything, ESCs or servos, the operating range is 1000 to 2000 PWM. For ESCs, yes, there is this 900 PWM that we better configure on the other end, set to 900 if it is an ESC, so we can wake them up. This is important. All right, but basically once it's all done, we configured it all right to the correct range that we want. This should work. You don't need to reboot anything. For this to work, you can set the fail values if you want to, although I actually never use them. This, again, it's in the same order as what I noticed earlier. So it's like ID 1 is 1, ID 11 is 11. You can try to change these, although I would recommend against that because that's just, again, going to be very confusing. At least there is some structure to it, yeah, you can easily remember it. If you wish to send SM like that Mavlink actuator output for servo, you can enable Mavlink over here. It can be used for debugging purposes, but you probably don't need that. So I mean, by default it's disabled.